So it's a bit more difficult to divide a polynomial by a polynomial. And we're going to look at a few problems, mostly trinomials divided by a binomial. And I want you to notice that the problems are going to descend, so x to the second power, then 3x to the first power, then the constant. When they do not descend like that, you have to rearrange the problem. But before we do this, so that you can understand the process, I want you to know that it's much like a problem that's a long division problem. So let's go fix that back to being, I'll leave that. 236, and let's divide that by the number 5. So when we divide that way long ago, when we learned to do long division, we said 5 goes into 2. No. But 5 goes into 23. Yes, 4 times. We put the 4 up here because 4 times 5 is 20, and we'd put that 20 right below this 23. Don't think of it as 236, but right below that 23. And then when doing long division, we'd subtract. So 3 minus 0 is nothing. 2 minus 2 is 3 minus 0 is 3, and 2 minus 2 is nothing. And then we'd bring down the 6, and we do that step again. So we'd say 5 goes into 36. How many times? And we'd go, oh, it goes in 7 times, because 5 times 7 is 35. And then we'd subtract again, and we'd have 1 left over. If we were doing this and did not want to round it to some number of decimal places, we could stop here and say that we had 47 with a remainder of 1. But another way to write this, 236 divided by 5, is as a mixed fraction, and that would be 47 and 1/5, the divisor, 1 over 5. So we're going to do this polynomial, trinomial divided by a binomial, in the same fashion. So we're going to put the x squared plus the 3x minus the 10 under that division bar, and over here we'll put our divisor, x minus 2. And then what I'm going to ask you, over here 5 goes into 23 4 times. So I'm going to ask you, how many times does x go into x squared? Pause and think about that for a minute. X goes into x squared. A lot of people say 2. This is what I'm saying when I say that to you. I'm asking you, how many times does x go into x squared? And when you divide like that, you subtract your exponents. So x to the second over x to the first is just x to the first. It's going to be easier from now on to go ahead and just say, what should I put up here so that when I multiply it by x, I get this exactly? That's what I want to have happen. And x times x will give me this x squared. Remember here, 4 times 5 gave me the 20. That's what I did, 4 times this. So now I'm going to take x times the x minus 2. I'm going to put it off to the side here. X times the x minus 2 is what I'm going to put right here. So x times x is x squared. X times a minus 2 is a minus 2x. All right, over here when I put the 20, I subtracted. So when I want to take this and subtract this, whenever you subtract, you add the opposite. And so I'm going to change this one's sign, and I'm going to change that one's sign, because therefore I will be subtracting, which is to add the opposite. Would you notice that this x squared and that negative x squared, they matched prior to now, and now when I combine them, they add together to be nothing, which is what you want. And then 3x and 2x adds to be 5x here, so I'm going to put the 5x down, and then I'll bring down the minus 10, just like I brought this 6 down and went about that process again. So now I'm going to ask you, I want to get a 5x. So what does x need to be multiplied by in order to get a 5x? Well, of course, it's got to be multiplied by 5. So much like over here, the 7 got multiplied by the 5 to get the 35. I'm going to take this 5 and multiply it by x minus 2 and put it right here. So I'm going to take the 5 times the x minus 2, and I'll get 5x. Oh, that's good, because I want these to match. And a minus 10 right there. Now, these don't necessarily always match, but When there is no remainder, that will be the case. Remember, you're subtracting next. So I'm going to change this sign and change this sign, and I have a remainder of 0. So my answer for this problem is just the x plus 5 because I have a remainder of 0. So that's just my answer. Let's see. I think the next one is going to have a remainder of 0. So why don't you go ahead and pause the video and do that one as well. Come back and see how you do. So we've got the x squared plus the 4x minus the 21, and I want to divide that by x minus 3. So I'm going to need to put an x up here because when I multiply that by x, I'll get this x squared. So again, that x up on top wants to be multiplied by the divisor now, and that expression I want to put right here. And so here's a minus 3x, and then I'm going to subtract. So I'm going to change the sign and change the sign, and these will always be nothing. These add this time to be 7x, and then I'm going to bring down my minus 21 and do the process again. Because this is 7x and I have an x here, I need a 7 right here, because 7 times that divisor of x minus 3 is going to give me this 7x right here, and 7 times minus 3 is a minus 21. And then when I change these signs, I get a remainder of 0. So my answer for this problem is x plus 7. I'm going to do one more problem and then take a break in this video and have you do some practice. But this next problem, when you divide the 3x squared plus the 4x minus the 5 by this x plus 2, we're not going to get a remainder of 0 this time. Little bit different too now. We have a 3x squared here. So I need to put a 3x up here because when I multiply it by this x, it will give me 3x squared. So again, I like to write out here what I'm doing. So that 3x up on top multiplied by the divisor is going to go right above this line. So this is 3x squared. This is 6x. And then I'm going to change my signs. This is a plus, now it's a minus. The first terms disappear, and 4x and a negative 6x combine to be a negative 2x, and bring down your minus 5. I'm going to need a minus 2 up here because when I multiply that by x, it will give me this minus 2x. So again, I am now taking that minus 2 and multiplying it by the divisor of x plus 2. That will give me here a minus 2x, and right here a minus 4. Whatever you do, don't forget to change the signs right here because you're subtracting. So these both become positive. This problem has a remainder, negative 5 and 4, of a negative 1. And my answer of the 3x minus 2, I won't just put r, 1. I'm just going to show that negative 1 in the numerator over the divisor of x plus 2. So I'm showing this as a mixed fraction, if you will. This plus sign doesn't have to be here. You could have this minus sign over here because plus a negative is the same thing as minus 1 over x plus 2. This is my final answer for this. Go ahead and do number 11. And it happens that its remainder is 0. So if you go ahead and do that, that'd be great. I was hoping I'd given you another problem with a remainder. Surely, boy, I just don't see one in these notes. But I'll come back and check with you in the next video.